Hey everybody, so this video is going to be a remake of one of the early videos I did. It was a pretty popular video, but the sound and video quality was absolutely terrible. It was very annoying to watch, so I've been promising to remake it. I thought, well, now's the time. So right here I'm going to describe how I would build a old E-model 40-pin cat for say 650 horse roughly, and build it in a way that's going to last 1,000,000 miles. Build it to be bulletproof, upgrade it to be more like one of the newer C15s, you know, as much as you can. So anyway, I want to first talk about what's the difference between a 40 pin and a 70 pin. A lot of people don't understand the differences, don't even know what I'm talking about when I say 40 pin versus 70 pin. The pin numbers, 40 pin, that refers to the number of pins in the connector on the ECM. And so there's three 40 pin E models. There's the 5EK, the 6TS, and the 1LW. Those three engines are very, very similar. But at the end of that, the cat started making 70 pin ECM, which was it started out with the 2WS, which is an E model, and then the 6NZ and the MBN. And those are the best engines cat ever made. Give me the choice of any engine, that's what I'm going to go for, is those 70 pin cats. But like I said, we can do a lot with the 40 pin, make them a totally reliable, good engine to use. So the first major improvement that Caterpillar made for the 70 pin over the 40 pin is in the cooling system. And you can see here on the block, this is the rear manifold off of the oil cooler, which would be right there, and it enters right underneath the number 4 cylinder here. Whereas we look at a 6NZ at the 70 pin, and we got our oil cooler and the manifold, and the window for it, where it goes into the block, is way back here. And so that is a huge improvement on coolant flow through the block. And this setup, you got your water pump here, and you got the main channel for coolant, you know, to flow around your liners and through your block. It's at number 4, and basically the back 2 cylinders are cut off from good circulation and flow. There's coolant back there, but it's not being moved through the engine like it is on the first 4. And what do you know about all the old cats and the horrible reputation they had is for dropping the number 5 and 6 liners and blowing the head gasket at 5 and 6. It's all because the back of the block wasn't getting proper cooling. Whereas with the setup here on the 6NZ, it had flow front to back, and they still blew them at 5 and 6, but not like they were before. This is much, much better circulation. So what we do on these old 40 pins to do as much as we can to improve circulation and flow is on the back side of this manifold, there's a hole here, it has a pipe plug in it normally. Take that out and put a 3/4 inch barb fitting in it here, and then you take this plug out of the block here and put a barb there and run a coolant hose between them, and now you at least have circulation. I'm sure, you know, it's probably still not as good as a 70 pin, but you're moving coolant, and it makes a difference. It definitely helps. So we do that to bring it back up to similar, you know, performance as a 70 pin. Now this here is the thermostat housing off of a 40 pin, and you can see right here is where the thermostat's located. You got a manifold and a housing for the thermostat. Well, on the 70 pins, they changed that housing and manifold, and you can see here it's a much bigger piece, and it's a dual thermostat. So you got two thermostats sitting back here versus the one in the 40 pin. Other than that, everything's the same as far as plumbing and everything. And so what we do on these 40 pins, if we're wanting to make a resilient engine, is we'll put a dual thermostat setup on it, and that adds the comfort of knowing that if you have a thermostat get stuck shut on a dual setup, the other one's still going to be working and opening. On a single thermostat, if you have one get stuck shut, you're done. It's going to start overheating. Now, you got two thermostats, one sticks shut. You're probably not going to notice right away. There's not going to be any real obvious indicator. And so further down the road, maybe the other one sticks shut. Yeah, but what are the odds of that? I mean, you know, we get into these engines from time to time and change thermostats when we're working around them and stuff sometimes. So basically, yeah, you could have both stick before catching it, but the odds are really, really improved for you that you're going to not have trouble versus a single thermostat. Now, if you get one that sticks open, you're going to notice that a lot earlier, because your heating and cooling just is going to be off because your thermostat's going to be open. You're not going to have that quick warm up when you're idling due to the thermostats being closed. So yeah, we convert to the dual setup, and then on top of that, often we got, you know, we're all if you're running hot, if you're hauling heavy, if your truck is, you know, say maybe a international or Freightliner that has a cat in it, those radiators typically didn't have the capacity that like Peterbilt and Kenworth did, so you got less cooling ability just because the radiators aren't as big. So if you look at the build sheets on these engines when they're new from the factory, often the trucks came with a 190-degree thermostat in them, and that's just hotter than anybody wants in any situation typically. And so you got to be careful ordering your thermostat in the first place. If you just tell your salesman, hey, I need a thermostat for this particular engine, they're just going to go off that and probably send you a 190 thermostat. At least put a 180 cat thermostat in it. But if you're fighting hot temperatures and stuff, we've found that if you put a Cummins thermostat in it, it's also marked 180 degrees, but for whatever reason, everybody says their truck runs cooler with the Cummins. I guess, I don't know if it's opening a little earlier or quicker, or has more flow once it's open. I don't know what the deal is, but it seems like everybody says, yeah, that made a difference. Sometimes even if it's a placebo effect, I'll take it. But I don't know, over several years, guys act like they notice it. So yeah, pick your option there, whatever you want to do. So the next big improvement that they made on a 70 pin versus a 40 is in the electronics and wiring, and in particular the timing sensors. This here is the cam sensor for a 40 pin, and that's the only indicator that the ECM has to know what position your cam and crank are in when the engine's running. If it goes bad, your engine's done. You're not, you know, you're just dead in the water. Now, when we get to these 70 pins, they move the timing sensor for the cam from the side of the case to back here, you know, behind the gear, and then they added a crank sensor right there at the front of the crankshaft. And so now we have two timing sensors, and the ECM knows exactly where the cam and the crank are all the time. If you lose one of those two sensors, you'll get a check engine light, but your engines don't keep running. Performance technically could maybe be hurt just a little bit, because it actually takes readings from cam and crank and adjusts the fuel just really spot on for peak performance. You'll lose that, but the engine keeps running till you get the problem fixed. Another big improvement the 70 pins have over the 40 pins is the ECMs themselves. They're more durable. They're better built, but especially when you look at these 40 pins, you see fuel lines going into and out of the ECM. The idea was that the ECM needed cooling, and so let's run fuel through it to cool it. This is something you see, like N14s did that on their ECMs, except for they had a cooling plate that the ECM actually bolted against to help cool it. Well, Cat thought, let's be brilliant and run fuel in the ECM. It's not a good design. Nobody wants to see the seals fail and your ECM leaking fuel. So yeah, basically on the 70 pins, they did away with that altogether and just spaced the ECM away from the block a little bit to give it some air gap, and it's fine. Now on these 40 pins, honestly, just bypass the ECM with your fuel lines and get rid of that fuel going through your ECM. It doesn't need it. It'll run just fine forever without the fuel cooling it. So yeah, so on the mechanical and physical side of things, going back to this cam gear and timing sensor on this 40 pin, the cam gear is probably one of the biggest failures Cat had when they made this 40 pin. They got their toner ring that the sensor reads off of back here behind the gear, and there's counterweights or balancing weights, I don't know what you call them, in the gear, and I think they're to take vibration out of the gear train, I believe. But the problem is they're so thin walled around that toner ring that every single gear cracks out. You pull a 40 pin, you pull the gear out, and I about guarantee you it's cracked in 2 or 3 places, if not 8 or 10. But there's nothing you can do about that. They don't have a upgrade on that for a 40 pin. You're just stuck with what you got, and it'll run with it cracked until the crack gets too big, and then you got to fix it. But yeah, I've got a whole video on that. If you look at my videos on my page. But anyway, on the 70 pin, they did redesign that cam gear, and that's why they relocated the sensor for that cam gear in order to correct that problem, keep the gear from cracking. So that's something you just can't really do anything about, but you should know about on the 40 pins, because there's a good chance someday you'll have to deal with that. And the last mechanical, physical part of this engine that they really improved on is the oil pans on these. Now, this is the 70 pin, and I think you can see the bottom of the block and the oil pan there. Well, there's a big fat rubber spacer there and gasket there, and then there's grommets that go on each bolt that hold it up to the block, and there's rubber isolators squeeze everything together, and that's a far superior design as compared to the old setup. The old setup, they had paper gaskets. They had twice as many bolts, and it was just bolted tight to the block. And so these being aluminum pans for whatever reason, they did not like it. And those old oil pans would crack right in this corner, often on both sides. I mean, they could get cracks in the back of the sump also, but they are notorious for cracking. And you could weld them. You could have an awesome welder weld it for you, and about 85 to 90% of the time, those cracks will come back, and your only option is to buy a really expensive pan. Well, when they redesigned everything on this 70 pin, they gave that aluminum pan a whole lot more isolation, and just all the rubber there, it must have insulated enough that it's not cracking anymore. Not an issue. And one of the things you can do is you can move that entire oil pan, gasket, and isolator setup to the old block, because you can see this has bolts every 3 inches all the way around. Well, on the 70 pin block, they got all those bolt holes just the same, but they only use every other one. And so, it'll line up just fine, and you're going to be spending a good bit of money, but you can put that newer design oil pan on an older engine and save yourself some headache and some oil leaks. So that's the differences between the engines, the 40 pin and the 70 pin. So let's go on to how are we going to build this engine for both performance and longevity. First thing is, because I'm standing in front of it right now, is I'd change out the fuel pump. Honestly, you wouldn't have to change the fuel pump. You could, instead of changing out, you could shim the spring in it. But if we're rebuilding an engine, let's put a new pump on it. And the pump you want to buy is off of a SDP Cat engine. That's the ones that they made in 08. That fuel pump, because of the fuel system on that particular engine, they needed more pressure. And so that fuel pump, it'll put out another 30 psi or so over what a stock pump will. It'll gain you some power across the board. All right, so now what are we going to put in the engine block? There's a couple options here. I mean, you could just put the factory piston kits in it, and I'd be totally comfortable doing that. The weak point of these 40 pin and 70 pins is their pistons had aluminum skirts on them, and those are sensitive to heat. It's a lot easier to score one of those and damage a cylinder with too much heat. Your Acer engines that Cat eventually built, they had single piece solid steel pistons, and those are a lot more durable when it comes to heat. IPD does make a single steel piston for these. I've used them in a few engines. It's a high performance option. I've never had any trouble with them. I like using OEM parts normally, but I haven't had any trouble, and it does get you away from that aluminum skirt. I've had Caterpillar reps tell me that, oh yeah, Caterpillar's going to come out with a single steel piece piston for these engines, and they've told me that, I don't know, a couple times at least, and told me, oh yeah, end of this year. It hasn't happened. I'm not holding my breath for it, but it'd be cool if they did. Now, when it comes to the cylinder head, for the horsepower we're talking, if we're going to build this for 650 horsepower, I feel totally comfortable and fine just putting a stock head on it and setting my liner protrusion to 5.5 to 6 thousandths protrusion. But if we're really truly going for longevity and you're building it to be bulletproof, I'd really recommend having the head O-ringed. Locally here, we've got a machine shop that can cut the heads and O-ring them for us. I would guess most people don't have that option available to them. And so I'd point everybody to buying their heads from APC. It's American Premium Castings out of Washington State. Those guys are awesome. They're really good to deal with and work with, and their heads are really high quality. And actually, I'd say they've got an edge on Cat in several areas. For one, that you can have them O-ringed. You don't have to buy an O-ring from APC, but they got that option. Their heads actually flow 35% more coolant in them, and so when I've used these heads, guys are shocked with how much cooler the engine runs, to the point where we're putting 180-degree Cat thermostats in rather than the Cummins ones, because they just don't need that much cooling. The other thing, APC claims that they've got more nickel in their head than Cat does, making them a harder head and less prone to cracking. And they have a high performance option as well, where you can get better, stiffer springs and stuff. They all have iconal valves, which Cat does now too. But anyway, check out APC. They're a better head for less money than you can buy a Cat head. I like them, and I'll endorse them. Now, coming around to the exhaust side of the engine, on these exhaust manifolds, you can go ahead and put the factory exhaust manifold back on. It'll serve you just fine. If you want to up the performance a little bit, you know, we can put an aftermarket manifold on. They do tend to make a difference. I know I had one friend that he had a I think it might have been a PDI either at or Bully Dog manifold on his engine, but he is running stock Cat turbos, and just repeatedly, time after time, he was breaking the shafts on the turbos. And eventually he swapped that aftermarket manifold back to the factory Cat manifold, and he stopped snapping shafts in his turbo. I just say that as a, you know, I just say that to give you an idea of what I've seen myself personally as to the difference a manifold can make on an exhaust system. So again, I'd recommend Speed Steed. I've used a few of theirs, and they're a single piece steel, billet steel manifold. They're real nice looking, and they don't have slip joints that are going to leak on you. People say you can't have a single piece exhaust manifold. It needs to be able to expand and move and everything. And yet I've used these manifolds and I haven't had any trouble. I think what's going on is Speed Steed actually knows what they're doing and have it figured out with that billet steel. If you look at it, the grain of that steel is longwise on the manifold. And so my belief is when this manifold expands and contracts, it's all in that linear direction, or at least the major movement is. And so if you look at the manifold, they've got here on number 3, they got round holes for those two studs, but then every other hole for the studs is slotted. And so I believe what they've done is they've decided to center the manifold on number 3 and then allow the manifold to move back and forth. And those slots will allow for the movement without destroying studs or blowing gaskets. That's my theory anyways. Could be wrong about that, but I think that's what's going on. The other manifold, you know, if you rather have the slip joints, get a Bully Dog. Don't get a PDI. Their seals at the slip joints leak, and you won't like it. It's irritating, and I do have a fix for that, but you're better off just not buying the PDI. So attached to the manifold, we got our turbo. For that, I'm going to recommend you get a non-wastegated Borg-Warner, what they call a quad 0. The part number ends in 0000, so that's why they call that. Anyway, that turbo is good for a wide range of engines. I mean, all the way from probably a 475 up to 750 horse. That turbo will cover it, and it'd be perfect for the power range that we're talking about right now. And then when it comes to tuning the engine, I would recommend just going with factory Cat tuning. I feel like Caterpillar knows their engines the best, and most of the time, for most applications where we're not doing a huge build, I think you run with a Cat tune and you're going to get the best performance and fuel mileage and everything else. Their engineers aren't dumb. But while I say use a factory Cat tune, I would recommend that you get a 550 brake saver file put in it. The brake saver, if you're not familiar with it, is an engine brake that sits back in your flywheel housing, and it's a big complicated system you don't see very much anymore, but basically that brake saver just eats up a lot of horsepower, at least 50 horse. And so if you put that brake saver tune in, you're going to put a 600 horsepower file in. Along with the other modifications that we're doing and stuff, we're going to be getting up, 650 horse or more. Now, while we're talking about the tuning and such, I want to say stick to your factory OEM injectors in the engine. Don't buy aftermarket. I've never seen one that wasn't junk. They've cost me so much money. Anytime you get one from aftermarket, the salesman's always telling you, oh, it's a Cat injector. Well, okay, maybe it was originally a Cat injector, but it wasn't remanned by Cat, and it makes a difference. The aftermarket, they claim we rebuild them with the same machines that Cat do. And yet, if you get an injector from Cat that's a reman, they give you a trim code that goes with the injector. The aftermarket ones, they give you a number, but it's a universal number that you put in for every single injector. They claim that they've dialed in the injectors closer than Cat, and so they don't need a trim code to adjust the fuel in. And frankly, they're lying. They're not rebuilding them to the same specs as Cat, and they don't run smooth. I've had to rebuild entire engines due to bad injectors that were aftermarket, brand new injectors, and just destroyed engines. I won't use them. So, and then again, like I said, don't have your Cat injectors float or anything like that. Just stick with what you got in it. You don't need to go to a bigger injector either. If you got 57s in your engine, you don't need to put 58s in it. You can do everything in the tuning to get all the power you need out of those 57s. There's nothing wrong with them. And going back to our 70 pins, don't ever put 58s in a 70 pin. There aren't all that many files for 58s in a 70 pin, and they just dump too much fuel, and you can't control it, and you build heat. Instead, on a 70 pin, you can get 1,000 horse out of 57s if you got the right tuning. On every engine rebuild, we want to replace the harmonic balancer. It's just good practice. If you got a bad balancer, you're going to break your crankshaft. So just, if you're doing it, do it right. Replace the balancer while you're there. So when you're dealing with an old 40-pin engine, you need to watch out for these flywheels. If your engine originally wasn't very high horsepower, it could have this particular flywheel in it. And the opening here is like about 8.5 inches roughly. And if you got that flywheel, you're limited to like a 1860 clutch. And if you're going to make the sort of power we're talking, you want a 2050 clutch. And so you'll have to get a different flywheel that has a bigger opening if you got this one here. The bigger flywheel, I think it's roughly about 10 inches across there, and that'll allow you to hold that bigger clutch. Finally, I mean, if we're going to rebuild the engine, how about the air compressor? Now, this is the air compressor that everybody wants, but it's not the one that most people have. Usually, what you see on these engines is a two-flow 550. They're pretty well standard, and you know they'll do the job. But if you're going to replace it, I would encourage you to upgrade to a two-flow 750. And the price is going to be the same. It looks pretty well identical, but it's going to build air noticeably faster. Furthermore, when you're buying an air compressor, don't get it from Cat. You're going to pay, you know, a couple $100 extra for yellow paint, but Cat doesn't make their own air compressors. Bendix makes them, so just go ahead and get your air compressor from Bendix instead and save yourself some money there. So that's how I'd build this engine if it was me and going in my truck. Hope this helped y'all. If you got any questions, ask them in the comments. And if you thought the video is worth watching, like it and subscribe to my channel. I appreciate it. And I'll talk to y'all later.